Alright, this video is about collisions. We're going to look at particularly elastic collisions and recoil collisions. Now, this is momentum lesson 2 because momentum is always conserved within collisions. Now, there are 3 types of collisions. Elastic. Elastic collisions are when things bounce off each other. Recoil is when they start together and spring apart. So an example of a recoil is a cannon shooting a cannonball. Beforehand, they're both sitting still, and then they fire, and the cannonball goes one way and the cannon goes the other. Same idea with a gun, the kickback. It's the recoil of the rifle. And the third type of collision is the inelastic. We're going to look at inelastic collisions next time. Inelastic are when 2 things stick together after they collide. But for all 3 of these types of collisions, momentum is conserved, which means your momentum before equals your momentum after. So let's think about this. Elastic collision. The momentum before. You have 2 objects. In this case, they're coming towards each other. That does not necessarily have to be the case. They could be both going in the same direction. As long as the one behind is going faster, it'll catch up and collide eventually. Now, velocity. Velocity cares about direction. So in these problems, we care about direction as well. Okay? But momentum before. All we do is we say, okay, this object has momentum, and this object has momentum. Okay? Add them together. Alright? Momentum of object 1 plus momentum of object 2, keeping direction in mind. So that's before the collision. Now, after they collide, they bounce apart. And they'll bounce apart at different speeds. Think about pool balls. If you're playing pool, you know, you start with 2 balls, they both have momentum, you strike it with the cue ball, and then they both go off at a different angle. So they have different momentums afterwards. Okay, same mass, still m1, m2, but now we have a third and a fourth velocity. Okay, v3 is just the after velocity of mass 1. v4 is the after velocity of mass 2. Okay? While if you go back, v1 is the before velocity of m1. v2 is the before velocity of the second mass. So in the end, we end up with this awesome equation. And this is the equation that's in your reference table. The second one right here. m1v1 plus m2v2 equals m1v3 plus m2v4. Now that looks complicated. There's 4 different velocities. You'll be given most of those. You just have to remember that this half is the after, this half is the before. Okay? Now recoil. Recoil is the same initial equation. You care about the momentum before. So you have m1v1, m2v2. But here's the thing. Recoil is like a special elastic collision type idea because before they're both sitting still. That's the very definition of recoil. Recoil means that your momentum before is 0 because both objects have a 0 velocity. So your momentum before is equal to 0. And then something happens and it explodes, blows apart. A lot of times we have, you know, a gun and we have the bullet and the recoil, or 2 things in space starting at rest and pushing off from each other, or something along that lines. And then you have the after. The after is the exact same thing as the after for an elastic collision. m1v3, m2v4. So you just have the momentum of each of the objects after. So if you plug it in, we have the same initial equation. It's just in this case, recoil is special, and recoil, initially it equals 0. So if you simplify it down, you can subtract this from both sides, and you get this in the end. Okay? This is the equation given to you on the reference table. You can get there by knowing its recoil. By just saying, okay, initially it's equal to 0, so each of our other pieces have to have equal and opposite momentum. Let's look at an example. Elastic collision. Two hockey players are skating straight towards each other, trying to get the puck. A 50 kilogram, so I'm going to make him our M1. It doesn't matter which one's M1 and which one's M2, as long as you're consistent. In this case, M1 is going to be the 50 kilogram player, and he's going 2 meters per second east. So velocity of positive 2. The 70 kilogram hockey player is heading 3 meters per second west. So -3. Now this is your second mass, this is also the second velocity, and this is your first velocity. Okay, M1, mass of the first mass before. Okay, so V1 is just the velocity of the first mass before. Now M1 also has a V3, which is basically the velocity after, and M2 has a V4, which is the velocity after. So after they collide, the first player, the 50 kilogram, bounces back at 1 meter per second. So he goes back at a -1 meter per second. What's the velocity in direction of the second? So we're looking for V4. So we plug it in. M1V1 plus M2V2 equals M1V3 plus M2V4, right out of your reference table. Now we plug in our values. 50 times 2 plus M2 is 70 times -3 equals 50 times -1 plus M2 70 plus V4, which we're solving for. Now all we got to do is simplify this down. So 100, 50 times 2, plus -210 equals -50 plus 70 V4. Combine this side, you get -110 equals -50 plus 70 V4. Add 50 to both sides, and you get 60 equals 70 V4. So 60 divided by 70, because you got to divide 70 by both sides, and you get 0.86. So that's its velocity. Now its direction is positive, so it's going in the east, right? Velocity came out positive, so it's a, oh, sorry, I lied. Velocity came out negative, because that's a -60. So -8.6, so it came out west. Alright, let's look at the same problem, only recoil this time. Alright, so we have the same initial equation, M1V1, M2V2 equals M1V3 plus M2V4. Okay, and the same 6 variables. Now it's a recoil. And you can see that they start off facing, staring each other's eyes intently, and then they push off. So basically they're starting with their initial velocities equal to 0. Okay, so both of these are going to equal 0. Now a 50 kilogram player travels 1.2 meters per second east after they push off. So that's a positive 1.2. The 70 kilogram player goes off at some unknown velocity. Alright, well, let's plug it in. M1 50 times positive 1.2 plus 70 times V4. So we get 50 times 1.2 equals 60. So 0 equals 60 plus 70 V4 minus both sides by 60. Negative 60 equals 70 V4. Well, 60 divided by 70, as we know, is 0.86. So V4 equals negative 0.86. Okay? So recoil, it's actually easier than elastic because those zeros just make things go away. So it makes life so much easier. Alright, that's it for the lesson. Don't forget to complete your homework. Good luck.